secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth. Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth. Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth. Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth. Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth. Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth. Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Miss the class? No worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth.
Good morning, everyone. We're setting up.
Good morning, Miss.
Morning.
Good morning.
Good morning.
Good morning, everyone. Welcome.
Thank you.
Primary and secondary students, the Ministry of Education and Youth has provided a wide range of video resources to support your learning needs right at your fingertips. Mr. Class, no worries. Catch up on any subject by watching the Ministry's 24-hour e-homeschool network. Watch EHSN content on YouTube, the Ready TV network, PBCJ, or just check your local cable listing for EHSN primary and secondary channels. EHSN, the official educational video channel of the Ministry of Education and Youth.
Good morning, everyone. Welcome to all our students, teachers, educators, all. We're about to officially start. We ask that you keep your mics muted and await further instructions. Thank you. We will now have a song to begin our devotional exercise, after which Mr. Avail Russell will do for us the opening prayer.
موتناش الصاروخ بده يموتنا الجوع. احنا بالنسبه لنا في الخيم مش عايشين.
love you, Lord. Oh, your mercy never fails me. In all my days, I've been held in your hands. From the moment that I wake up until I lay my head, oh, I will sing of the goodness of God. And all my life you have been faithful. All my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. I love your voice. You have led me through the fire in my darkest night. You are close like no other. I've known you as a father. I've known you as a friend. Oh, I have lived in the goodness of God. Oh, and all my life you have been faithful. All my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. Your goodness is running after, it's running after me. With my life laid down, I'm surrendered now. I give you everything. Your goodness is running after, it's running after me. And all my life you have been faithful. All my life you have been so, so good. With every breath that I am able, oh, I will sing of the goodness of God.
Great. So now we'll invite fellow student Aviel Russell to open for us in prayer. Go ahead, Aviel. Aviel Russell. All right, we're waiting for Aviel to pray so that we can start the proceedings. Aviel, are you hearing me?
Oh, he's trying to unmute. Hold on a minute, Aviel.
He was.
Okay, yeah.
Go
Lord
ahead,
God,
Aviel. Yes.
Lord God, we thank you for waking us up this morning. and allowing us to meet here today. We thank you for the Ministry of Education and for putting this meeting in place. We thank you for the presenter, Dr. Campbell, who will explain and guide us to success. We hope through your guidance as well as the ministry's help, we'll be able to get through this session. We hope the students here will understand, and so that when the exam comes, they will be able to do well and get highly proficient and go to their first choice. Continue to bless us, bless and guide us, as well as our parents through these times. In Jesus' name, amen.
Amen. Thank you, Aviel. All right, so we will officially begin our proceedings today. Welcome to all our students. Please be reminded that the session is being live streamed on the JTC, that's the Jamaica Teaching Council's YouTube page. And so you can share the link that was posted in the chat with other friends and colleagues. Please note the objectives that we want to achieve for this session today. We're hoping to review some of the major concepts that you would have come across in your grade 6 NSC Science. We will also like to share with you and have you explore some of the competencies that are being assessed in the curriculum-based test for science. And we hope that at the end of this session, you'll be able to reflect on what it is that you understand about the concepts and practices and skills for science that, of course, you would need to be prepared for the upcoming examinations. At this point, I'm going to invite Mrs. Charlotte Comock, one of our education officers for language arts, to share some online meeting protocols that we need to observe for this session. Mrs. Comock, I'll allow you to share. We're not hearing you, Mrs. Comock.
Good morning, students and the parents. All right, so students, we're going to be here online, and I just want to remind you of some behaviors that we're expecting from you. So we're expecting you to keep your microphone muted. So please keep your microphone muted at all times unless you are answering a question and you have been identified by the host, okay? We want you to type your questions or your comments in the chat. Use the raise hand feature for those of you on Zoom. Use the raise hand feature to make any comment or to ask any questions that you might have. Of course, we want you to feel free to ask your questions and make your comments and share your ideas. And most importantly, we are asking you to be respectful at all times. Can you hear me, Dr. Campbell?
Yes, we're hearing you
Okay.
loud and clear.
Right. So be respectful at all times. We're asking you to avoid foul language, insults, or offensive remarks. All right. We're being respectful today. We want you to stay on topic. So keep all the irrelevant conversation out of Zoom. We want you to focus on what's happening, and any conversation that you're having in the chat must be related to the presentation. All right. We also want you not to spam the chat. So we don't want to see all these emojis coming in or the same question coming at the same time. Just try not to spam the chat, because we want to see really the important questions so that we can answer them and we can give the students feedback. All right. So we're asking you to follow all the guidelines. And if it is that you're not being respectful or you're making other students uncomfortable, we'll have no other
choice,
choice,
of course.
but to remove you from the meeting. All
Oh,
right.
yes,
And we're
we
expecting
will
those on
remove.
YouTube as well to follow the guidelines. We want everybody to be comfortable. Please, we don't want anybody to be offended. So remember, be respectful at all times. And if you're not following, we have no choice but to remove you. All right. So we hope you'll have a very, very good day, a productive day, and that you'll learn something and that you'll do well on your exams.
Thank you so much, Mrs. Comack. All right, I see we had a hand up. I'll just take this raised hand before we get into the proceedings. Chanel Doherty, if we can unmute her. You can go ahead and speak. Are we seeing that person, Mrs. Chanel? Just give a second. So you would have heard the protocols that we need to observe. Chanel, I'm not seeing her name. All
There are
right.
some students complaining that they're not hearing.
Well, I'm not sure where
Check
I
your
was hearing
audio,
earlier.
please.
Yes. Okay, students, check your audio. All right. If you have a comment, just put it in the chat. If you're not hearing, still not hearing, you may need to log off and to come back on to check if it's an issue with your device audio. All right. So if you did not put on the audio, you will not be able to hear anything. Okay, so let's continue. We're inviting you to watch this video. And as you watch the video, there are some questions we have that we wanted to take note of. All right, if I can find back my video. Are you hearing? This doesn't seem to be.
No, we're not hearing.
Okay, let me reshare. Still not hearing?
No.
I'm not sure what's happening. Oh well, something can go wrong, it will go wrong.
Did you remember to share the audio?
I did, it's just not moving. Sorry about that. Okay, all right, just a second. Or we'll come back to this video. For some reason, it is not sharing. All right, no problems. We had our sound checked. We'll try this one more time. Okay. All right, we'll skip that. All right, and we'll check to see what's happening there. So we're going to start with the unit on environments. All right, and so there are some major concepts that you would have had to cover in your NSC science. And so we're checking, first of all, to see that you have understood these concepts. Here is a concept map that essentially summarizes some of the concepts that you would have covered. So what are the features of different environments, right? And so you would have been introduced to the different types of environments, and there are different features, which includes, you can put in the chat, students, or if you're on YouTube, you could put some of those features that we'd normally look for as we classify the different environments. And of course, we note some of the ways in which these resources can be conserved. And generally speaking, we're encouraged to recycle, produce less waste, reduce our use of fuels, and of course, dispose of our waste properly. And then we look at the effects of man's activities on the environment. So we know man has the propensity or the capacity to affect his environment, both positively and negatively. Many of the effects listed here are negative ones, right? Through deforestation, littering, releasing of certain compounds, we call them CFCs, into the atmosphere, releasing of industrial waste, burning of fossil fuels, and of course, all of these can lead to other issues related to climate change, global warming, habitat loss, soil erosion, air, land, and water pollution. All right, so let's look at one of our first questions that we will be examining today. You're asked to listen carefully, send your answers in the chat. Here is a question that we're trying to answer. A student measured the time it takes for water to pass through different soil samples, and we're shown this diagram. The question we're answering is, what should the student do to make sure the results are accurate? And so our first question is, what do we mean by accurate results? How can we obtain more accurate or reliable results? Usually,
Dr.
accurate
Taylor, the audio is very low.
has to do with whether or not we can trust the results. And to do this, we normally need to repeat the experiment many times. So, what should the student do to make sure the results are accurate? Exactly. The student should test each soil sample many times. Now let's look at the second part to this question. The student was given some results in the table shown, and they're to use the information to answer item 8. What is the most likely conclusion for the investigation? First of all, you're invited to examine the table to look for patterns or trends. So look at the data, look at the volume of water that was added, the volume that was collected after it passed through the soil sample, and the time that was taken for the water to pass through. So let's look again. What is the most likely conclusion for this investigation? Is it that water takes a longer time to pass through loam? Water takes a shorter time to pass through clay? Loam soil has the least water holding capacity, or sand soil has the least water holding capacity? Based on the results in the table, what is the most likely conclusion? You're right. Sandy soil has the least water holding capacity. Why? Because in the table provided, it took 1 minute for the water to pass through the sand, whereas it took a longer time to pass through the loam and the clay.
All right.
Here's our second question. We have a graph provided that shows the number of cyclones, or we can call that hurricanes, in our part of the world that formed off country Z from 1990 to 2020. And we're asked what conclusions can be made from the graph. So again, you're invited to examine the graph. Yes, look at what is represented. Are you able to see the months when the cyclones are normally formed and how often we usually have cyclones in these months? So, what conclusions can be made from the graph? Is it that cyclones form all throughout the year? Cyclones form between December to April. Cyclones only occur during December and March, or cyclone occurs in February every year. So which is the best or most likely conclusion? That's correct. Conditions suitable for cyclones to develop are present from December to April.
Okay, so we're gonna check the chat to see your responses. For some reason, the audio is a bit low, so I'm just gonna ask you to increase the audio on your device to see if you can hear. Okay, so let's see now. Were there any correct responses in the chat, Mrs. Comock, Mrs. Russell? All right, so I see some responses here. Right. Yes,
A
I'm
lot of
sorry.
students had B and for the answer. I guess that's the last.
Okay, for the last one, right?
Okay.
For the last one, it was B and the others. All right, so I see quite a few responses here. All right, so colleagues, students, again, I'm sorry the audio is a bit low. If you could turn up the audio on your device, maybe that will help us a bit. All right, so let us continue. We're gonna try again to see if we can get our video working. I'm not sure why it's copying out on me. So let's see if we can watch this video. If there is something that you don't understand, all right, let me take off this, see if I can better see what's happening here. Okay, so All right, there is some error, player error, where we're not able to get the video. All right, let's try again. All right. All right, seems as if we have to play the video afterwards because we're not able to get that video for some reason. All right, let's continue with our questions. All right, we'll try to see if we can get those videos afterwards, all right? Such a pity. They were very exciting videos. All right, we're looking at now the unit on light. And these are some of the major concepts that would be covered under light. And so we're going to ask you to respond to some of these questions. What do you remember about the properties of light, students? Do you know the properties of light? Can you share that in the chat? All right, so I see there are 2 hands raised. So we'll take one of them. If Mrs. Comer can help me to unmute, to unmute the student. Donna Shea Rochester. Are you able to share? Donna Rochester.
Miss, a property of light is refraction, reflection, and observation.
Observation. What do you mean by observation? So you got reflection and refraction. Can you think of anything else?
Miss.
Okay, all right. We can take one more comment from somebody who can add to those properties. Is there another property of light that we should be considering? Romian Gray. We can hear from Romian Gray. All right, I suppose the chat is, we're filling the chat. Okay, sorry about persons who are having trouble. Can we unmute somebody else? Yes, go ahead.
You have reflection, refraction, and absorption.
Absorption. All right, that's a little tricky. But there's one other property that is really the foundation property that affects almost everything else. What is that property? Let me see if I can find it in the chat. Light travels in a straight line, all right? So that of course affects everything else, right? All right, how does light interact with different materials? So you should have been exposed to how light interacts with transparent, translucent, shiny materials as shown by this concept map. So of course, as it interacts with different materials, we will see different things happening in terms of, for instance, on shiny materials, it is reflected, right? Of course, as it passes through different materials, especially when we look at what we call the different medium or media, right? The light can be refracted, okay? And so we look at how it passes through solids and the liquids, all right? And of course, light will travel in all directions from the source. Now, when light passes through some materials, like transparent materials, we know that all of the light passes through. And for translucent materials, it passes through partially. So some of that light would be blocked. Now, what about opaque materials? We're expecting that the light may not pass through. So it's not able to pass through. And so when that happens, we get the formation of shadows. And of course, if you would have done some investigations at your school, you would see that you can change the shape, the size of your shadow, right? Depending on how you position the object, as well as the distance that the object is from the light source. Is there anything else that we need to know about light? The properties of light and how light interacts with different materials? All right, so we're going to check and test our knowledge by looking at these questions on light. Again, you're invited to listen, put your answers in the chat, all right? Or if you have a comment, you can raise your hand. We'll see if we can facilitate your sharing with us orally. But turn up the volume or the audio on your device since the recording on my part is low. Listen carefully. Here is our first question. The arrow shows the light ray from a flashlight that is shined onto a mirror. We're to use this information to answer which direction will the light ray most likely go after it hits the mirror. So, let us examine the diagrams carefully. Look at the direction that the light rays are pointing to determine if that is the direction that the light ray would go. When light usually hits a mirror, what do we know about the angle that the light ray will now take? Which property of light is shown? Yes, the light ray is reflected. So, when light touches or bounces off the surface of a mirror, what happens to the angle in which it is reflected? Yes, it is reflected or it bounces off at an angle relative to the angle that it hits the mirror. So, which direction then will the light ray most likely go after it hits the mirror? Exactly, correct. Our answer is B. Now let's examine a second question. We're asked to complete a statement to explain how a shadow is formed. And so the question is, how are shadows formed? Let's examine the answer options. Look at them very carefully. Is it formed when light passes through a transparent material? Is that the correct scientific concept? Is it formed when light passes through an opaque material? Is it formed when light is blocked by a transparent material? Or is it formed when light is blocked by an opaque material? Now, if we look carefully at the answer options, we will see that some of the statements, though they may seem correct, they're actually incorrect. Because although light, we know, will pass through a transparent material, that will not allow a shadow to be formed. And let's examine B. Will light pass through an opaque material? Definitely not. And so our best answer correct. Light when light is blocked by an opaque material, now that is when a shadow is formed. Here is our final question in this section. Students are investigating the formation of shadows and they have set up the experiment as shown. We're asked which of the students' predictions would be correct. So, what do you know about predictions or hypotheses? Yes, hypotheses or predictions suggest what we think will happen in the investigation. And so if you have done this experiment, you can make a guess as to what you think will happen. So let's examine the students' predictions. And we're looking to see which of them would actually be correct. Should we be making the box bigger in the investigation? If we make the box bigger, the shadow will get smaller. Is that correct? If we move the flashlight nearer to the screen, the shadow will get bigger. If we use a bigger flashlight, the shadow will get bigger. Should we be using a bigger flashlight in this investigation? If we move the box nearer to the light, the shadow will get smaller. So, which is the correct prediction? Yes. If we move the flashlight nearer the screen, the shadow will get bigger. All right. So I saw there were some hands raised. Can we take one of those hands, Mrs. Comack?
Sure, I'm going with Elaine. I think what's his name? Robian, what was his name? He
Yes.
wanted to share. I'm going to try and unmute everybody, and then they just mute back themselves quickly.
Okay, all right.
So go ahead, Robian. Guys, please mute yourselves. I have to unmute everybody because it's difficult to find him.
Okay, afterwards you can mute them back. All right, so who you wanted to answer?
I think his name is Robian or Rovian. I don't remember his name now.
Okay, Rovian or Rom.
No. Yes, sir.
Oh, yeah, you unmute.
Miss.
Romian?
Yes.
Go ahead, answer quickly.
Excuse me, miss.
There is another property of light.
Excuse
It's
me, miss.
also luminous, non-luminous, shiny, dull. You have the lens, you have mirror, and you have the source of the light.
All right, we probably can't unmute anybody else. Mrs. Comack?
No, we can't. So I muted back everybody. All right, let's try Summerton All Age. Let me see if I can unmute them for you. Go ahead, Summerton.
Summerton All Age.
Go ahead. All right, so I'm going to Anna Bailey.
Anna Bailey.
Excuse me, miss, quick question for the scientific, for the question, I didn't hear the answer for the last question they had.
The one on light?
Yeah, the one for
Okay.
the last one.
B, we said the answer was B.
Okay,
When I share my screen again, I'll show you the answer.
thank you.
Okay, you're welcome.
I'm going now to Jason Bignall, if you're taking one more.
Yes, I'll take one more.
Miss, for the last question on that about the flashlight and the box, miss, I think the answer is D, miss. Because if you move the box nearer to the light, the box will be blocking most of the light, so the light will get smaller, miss.
Okay, so remember where the focus is on the shadow, the formation of the shadow. I hope you're seeing
Yes,
my
miss.
screen, all right? And so based on the investigation, if we move the box nearer, is the same thing as moving the flashlight nearer, right? And so the shadow will actually get bigger. It wouldn't get smaller. You can probably check with your try it with your cell phone, for instance, using the flashlight, and get an object and try to move it backwards and forwards and see what happens to the shadow. All right? Okay?
Yes, miss.
All right, so let me try this video one more time and see if we can get it to play.
Good girl. Moses. Mo.
It's Kenza's turn.
No, nothing at all. Absolutely quiet. It's amazing.
But what have the microphones picked up? The decibel waveforms show the sound being generated by the birds in flight. Each spike is an individual wing beat. But with the barn owl, there's almost nothing. Even our array of super-sensitive microphones fail to pick up any sound of Kenza in flight. So how does a barn owl fly so silently? When air moves, it generates sound. The more movement, the greater the sound. The pigeon's large body and small wings mean it can't stay airborne without a lot of fast flapping. This creates turbulence in the feathers below. The peregrine has much larger wings, which it uses to build up speed and chase down its prey. The barn owl is far more graceful. Through the air, creating little more than a whisper in the feathers below.
Okay, students. All right. So using one word, describe what you saw and some of the questions that you may have. based on the video that you just watched? I see. So you're describing what you saw using a word, all right? Describing what you saw, yes, and you're also putting in the chat questions that you may have. So of course, remember, science is about asking questions, right? So after watching that, what questions could we put forward? Listen carefully. What questions could we ask? So I'm not just looking for a topic. I'm trying to have you think of some questions. All right, so I see a first question there. Let me see if I can grab that question. Oh dear. So somebody said, why were there sound waves in the air? What type of bird? How does sound travel? Yes. Yes. What about the fact that, yes, which bird made the least sound? Yes, keep them coming. What is sound? How do the owls make zero noise? Yes, that is the question. That is not the question, students. Why is it that with the other birds, we heard a sound, but with the owl, right, there was literally almost little sound. A matter of fact, the name of the video is called The Sound of Silence. And so we may want to find out what is the advantage for the owl to be basically moving as silently as it did. Anybody wants to respond to that one? Daniel Robinson, can we unmute Daniel Robinson to answer? What is the advantage for the owl? How does it affect its survival? Or how does it help its survival for it to be moving as silently as shown? Are we unmuting Daniel Robinson? All right, let me check the responses in the chat in the meantime.
All
Why
right.
did the owl make no noise? Yes, go ahead.
He's not answering, so I'm going to try Daniel Hunt.
Okay, Daniel Hunt.
So having
Yes.
been able to fly silently can help it when hunting. The prey cannot recognize it when it's coming, and if a predator is hunting it, it can easily escape without the predator being able to hear it.
All right, all right. Good job. So obviously, students, we can see that the adaptation for the owl is that it will be moving as silently as possible, right? To help it in its own survival as it hunts for prey. Yes, that means that it is able to come upon its prey and take them by surprise because they're really not hearing when the owl is approaching. All right, and that is very important. So as we look at sound, notice we're also looking at adaptations that these animals will make to their environment. All right, if you have any other questions, of course, related to the video, you can post it in the chat. And so now we're going to look at some of the concepts that we're...
Dr. Taylor,
Yes.
Donna Shea wants to speak.
Okay, Donna Shea, go ahead.
Miss, when the owl is hunting other animals, the other animals will not be able to hear the owl wings sound, because the owl wings it dampen the sound in the ear, so that the other prey or the other animals cannot hear the owl when he's coming.
All right, so if we look carefully, it may be a part of the reason, maybe the size of the wings, maybe that, because compared to the other birds had some larger wings, so that is a part of it. But certainly it's really one of the adaptations for the owl to help it to survive. All right, if you have any other questions or comments, you're invited to put that in the chat. So we're now basically going to be looking at some of the concepts that would have been coming out of that video looking on sound. So certainly some questions that were asked included how are sounds made? Do you know how sounds are made? Do you know how sounds travel? Do you know which materials sound will travel fastest through? Is that solids, liquids, or gases? And why would that be so? What would be the explanation for why sound will travel faster through one material compared to the other material? And what are some properties of sounds? All right, so this concept map on sounds can help to summarize some of those ideas, right? We know that sound is really caused from vibrations. So whatever you do, whether you hit an object, you pluck it, you knock it, you shake it, right? Once it causes vibrations, then we'll get a sound. And we know that it travels through the 3 states of matter, right? Solids, liquids, gases, and of course, air is mentioned here, but we know air is a mixture of gases, right? So, and in terms of properties, we can describe sound based on whether it's loud or soft, or whether it is high or low pitched. And the change that we see will depend on the vibrations that's produced. So if we have slow or fast vibrations, if there is small or large vibrations, then of course it will result in different properties of the sound. And certainly if we have sound that is considered to be unpleasant, or if it's too loud, then it can lead to noise pollution, can affect the hearing, can affect, cause damage to the eardrum. And of course, we know how to protect that using different materials, using different objects. Yes, like what? How do we protect our hearing or protect our ears from loud sounds? All right, put that in the chat. And of course, if we are thinking of working in an environment where we need to reduce the sound, then we can consider some of these actions: use of noise barriers, thick curtains, padded walls. Yes, think about what happens when you go to the cinema. Anybody watch a movie recently? Right? Look to see the materials that are used, the carpeting that is used. Probably ask some of those engineers or persons who work in that section, how do they soundproof that room to ensure that the sounds are kept inside, all right? All of that is the application of the concepts that you would have learned about sound. So we're going to now test our understanding by looking at 2 questions on sound. You're invited to listen carefully, increase the volume on your device if you're not hearing clearly, all right? And post your answers as you see in the chat. Here is our first question. A student made the instrument that is shown below using wood, string, and nails. When the instrument is plucked, different pitches are produced. And so we're to answer what features of the strings would change the pitch of the sound. So do you remember what the pitch is? What is the pitch of a sound? Yes, the pitch refers to how high or how low the sound is. No, the pitch is not the loudness of the sound, but rather how high or how low the sound is. Have you ever looked closely on the strings of a guitar? Let's look and see. What do you notice? Yes, some of the strings seem to be thin and others seem to be thick. And so the pitch that we hear may be related to how thin or how thick the strings are.
Let's look at this information. Look at the diagram that is given. What do you see? What do you notice about the strings? Yes, we would notice that some of the strings seem to be thicker than others. But also, we would notice that some of the strings seem to be longer or shorter than others. So let's examine the question again. What features of the strings will change the pitch of the sound? What is your answer? Correct. Both the length and the thickness of the strings would affect the pitch of the sound. Here is our second question. The length of some piano strings are shown and the pitch of the sound that they produce. We're asked to look at that information and to use it to determine which of the statements given is true. So, we first need to analyze all of the information presented. So we need to look at the lengths of the piano keys or strings, and we also need to look at the pitch of the sound that they produce. Do we notice anything? Let's look at the patterns. What do you see? What happens when we increase the length of the strings? What happens to the pitch? What happens when we decrease the length of the strings? What happens to the pitch? So let's look at the statements. Which is true? Is key C1 the shortest string? Look at the graph. Is that correct? Is the piano key C2 the longest string? Is that correct? Our statements must match the data that is given. So, let's examine what happens when we change the length of the strings. What happens to the pitch? As we move from C1 to C2, we notice that the length is decreasing. So what is happening to the pitch? Yes, the pitch is increasing. So which is our best answer? The best answer is that the shorter the string, so as we move from C1 to C2, which is the shortest string, the pitch increases. All right, so we'll take some responses. Or I see Daniel Robinson had the hand up from a long time ago. Let's hear from Daniel. Are we hearing from Daniel? All right. Mrs. Comock, who will we allow to give us a response here?
Let me try Jason Bignell. Go ahead, Jason.
Miss. So, Miss, I think that the answer for the piano keys, Miss, is A
Right.
and C.
The answer is?
A and C.
For which one?
The piano.
Yes,
The
Miss.
piano?
Yes.
Well,
Yes,
it is supposed to be not A. I think, let me see if I can go back to that. Based on the strings, sorry, my bad. Based on the strings that we're looking at, let's see if I can get that item. We're asked what two features would we change
So I think it has to be B and D, not A and C. You want to explain why you would have chosen A and C? I'm going to try to share my screen so that we can see the responses. Go ahead,
Yes.
explain why you would have chosen something else.
Miss, the reason I chose A and C, Miss, is because A said the bigger the string is, the lower the pitch, Miss.
Oh, you're looking at this, not the first one, the other one. You're looking at the other one.
Yes, Miss, the piano, Miss.
All right, so let's go to the piano. And the question was asked. Let's see if I can bring up that. So this is the question on the screen. Is that the one you're talking about?
Yes, Miss.
And you're choosing which one now? Which answer you're choosing?
A and C, Miss.
Okay, so this is only looking for one answer, right? And if you look at A is saying that C1 was the shortest string. Look at the diagram. Does C1 look like the shortest string?
No, Miss.
Right, so A could not be a part of the answer, all right?
Yes, Miss.
All right, no problem. All right, can we take one more?
Yeah, I'm gonna try St. Catherine Primary.
Okay. St. Catherine Primary.
All right, not hearing from them. Let me try Anthony Griffiths.
Okay, who is responding from St. Catherine?
C.
C for, okay, for the one that we're looking at. Your answer is C. Any reason why? Are we given a reason, St. Catherine? Why?
The answer would be C.
Why?
Miss, the answer would be C because of the shorter the string, the pitch would be higher.
Okay.
The distance between the object that you are flicking the string onto.
All right, so you're cracking up a bit, but students, when you're asked these questions, if, for instance, you're given data, whether it's in a table or diagram, you have to look at the data. So you're basing your answer on the information that is shown. So we would have seen that the shortest string was C2, and C2 had the highest pitch, right? So the shorter the string, the higher the pitch of the sound. All right, I'm going to invite you now to look at this video. Hopefully we can see it. Give me a minute. All right, I'm trying to come out of here, sorry. One sec. All right, so watch this carefully, all right? All right, so let's see if we can get some responses as to what's happening. All right, did you see anything that is worth mentioning? What happened? What did you notice as the ice melted? Can you think of why, for instance, it seemed as if the ice was melting faster on one of those materials than the other? Which material the ice melted faster on? And which one was the slowest? And what would be the reason for that observation? All right, let's see if we can take one comment. Donna Douglas Brown. You can go ahead and put your responses in the chat as well, students. Donna Douglas Brown, are we going to hear from Donna Douglas Brown? Okay, is there somebody else we can hear from? Mrs. Kamak?
Miss, I would say the ice smells faster and the aluminum, miss, because it's because it have more heat, miss. Well, the ice smells slower on the wood, miss, because it's not that much hot, miss. Well,
so why would one have more heat than the other?
Miss, because the aluminum, miss, is used to keep things heated, miss. So yes, miss.
So what property does it have? It is behaving as what type of material? Can you think of that answer? All right, we'll take one more person who wants to respond to that. Why? So it's good to note what is happening, what your observations are, but it's even better for you to now be able to explain why that happened, right? That's a skill that we call your ability to infer, right? So you note what you see, right? But can you explain that observation? Why did it melt faster on the aluminum compared to what was it? The last one, the one that took the longest would have been the wood, I think, right? So what's the difference in these materials? All right, can we take one more response?
I'm trying twin.
Twin?
Let's see if we can.
Mrs.
All right, let me try
Russell,
something
we're
else.
here
Let
now.
me try Aiden Henry.
Aiden Henry.
Go
ahead.
I would
Yes.
say because of the type of material it is made out of is why the ice melts faster on one.
Okay, so what do you know about those materials that would have caused that difference?
The material where I forgot
The
which
aluminum,
one.
yes.
Yes, that one it conducts heat more than the other material, so the ice would melt faster on that.
Okay, so substances or materials that are better conductors are able to heat up more quickly, yes, than others. Is that what you're saying? Aiden? Aiden is gone. All right, yes.
I'm gonna try Shay.
Shay, all right. Yeah, one last one.
Go ahead, Shay. Shay?
Shay's not ready. All right.
All right, let me try Zariah. Zariah?
Yes, miss.
Go ahead.
Answering, yes.
Miss, I think it would be a heat conductor.
Which one?
The aluminum.
Okay, so what about the plexiglass and the wood?
The plexiglass, it would be a let's see, insulter. No, insulator, sorry.
Insulator. Well, obviously it was the second fastest to melt, right? So it does conduct a bit, but certainly it's not as strong a conductor, or what we say, it's well, stronger conductor as the aluminum, right? And what's your explanation for the wood causing the ice to melt the slowest? What
Miss,
type of material is the wood?
Miss, I would say that it would be a since it can still conduct heat a little bit, so it would technically be a poor conductor of heat.
Otherwise called
an insulator.
An insulator. So really it's just looking at the strength of those materials as conductors or insulators, right? Okay, so the best conductor would attract or heat up much more quickly than the others, right? And so that is the reason for the change in how the ice melted. All right, so now we're going to look at a question on that topic, if we can. So basically, the video would have shown us that we have materials have different properties, all right? So based on their properties will of course influence their use. Okay, so if I wanted something that would heat up quickly, I would choose something that's probably a metal, right? And if I wanted something that would, you know, keep the heat in, right? Not lose the heat as quickly, then I'd probably choose an insulator. So the properties of materials influence their uses, and some of the properties that you would have covered in your science class, hopefully, you should have looked at transparency, how much light is able to pass through, right? Absorbency, how much liquid the material can absorb. There are other properties, of course. You can put some other properties not shown here in the chat. We look at the heat conductivity, as we were discussing just a while ago, how quickly heat passes through, and the magnetic properties, if they're able to be attracted to magnets. Are there other properties that we can consider that materials have? All right, please share those in the chat. I know you can talk about strength, you can talk about flexibility, you know, whether it is waterproof, right? So there are many properties, and of course, the things that we use them based on their properties. And when we're looking at materials, another important part of materials is to look at how we use them in terms of the safety protocols that must be observed. They must be labeled. They must have some certain safety symbols, for instance, for us to know how to use it, how to handle it and store it properly, and most importantly, how to dispose of the materials. All right. So again, we're going to invite you to listen and participate in some questions that are going to be shown. Increase the volume on your device. All right. Not quite there yet, but here is a question for you. There's a class that is investigating the best material for keeping their chocolate. So I guess they're having chocolate hot. Notice what they've done. They have taken 4 identical plastic cups, wrapped them in different materials. See the different materials here: newspaper, foil, food wrap, and bubble wrap. And they are putting in the same amount of chocolate drink, all right? And the question that is being asked is what property the material should have if it is best for keeping the drink hot. So that is the question. What property, we just discussed a while ago, some of the properties, what property should the material have if we need to keep the drink that is a chocolate hot? Which is the best property there? Or which is the most appropriate property for that question? All right, I'll just check the chat for these responses. I won't have individual responses. Okay, let's see what you came up with. Remember, we want to keep the drink hot, right? So if we want to keep the drink hot, do we need? Okay, so remember, look at the question, look at what the question is asking, right? It did ask you for whether it's newspaper or foil. They're asking about the property that the material should have. If we want to keep our drink hot, that means we want to keep in the heat. We don't want to lose the heat. So do we want something that is hard? Would that affect us in terms of the heat? No. Do we want something that is strong? Well, in this particular case, the strength would not be important. So what do we need? All right, let me go back to the chat. I see some persons put in insulators and some put in conductors. All right, so let us be clear. Remember, a conductor heats up very quickly, but it also loses that heat very quickly. So if you want something to keep the heat, right, you need an, what do we need? You need an insulator. Because if you chose a conductor, something that was a conductor, because it heats up quickly, it passes the heat. So it allows the heat to pass through very quickly. So it will pass out of it as well, right? So the conductor would not keep the drink hot, right? It would have to be an insulator. I hope we're understanding that. Is there anyone who is not understanding that particular concept? So let me explain again. I think I see that a lot of persons in the chat are saying conductors. Okay. So let me explain again. If you want to keep, all right, when you're at home, so let's see if we can make it applicable here. If you're at home and you're cold, what do you choose to wrap around with or to put on? Think about it. You probably choose a sweater, or you get a towel, or some of those you know, thick you know, sheets or that sort of thing, because you want that material, which is an insulator, when you put it over you or cover yourself with it, you want it to keep in the heat. Remember, insulators, the heat does not pass through it quickly. All right, so we need to understand this concept. So because it doesn't pass through the insulators or those types of materials very quickly, it is able to keep in the heat because the heat will not pass through quickly. If you use a conductor, the heat will pass through very quickly. All right, so we want to keep the heat in. So you need to choose something that the heat will not pass through very quickly through. All right, and that is an insulator. All right, so let's make sure that we're clear on that. So again, based on the video that we would have seen, we would have also recognized that we can change the states of matter. So in the example shown, the ice would have, what was that change of state? The ice would have melted, right? So how do we normally change the states of matter? We're hearing some talking. What can we do?
Good morning, Miss.
Yes, good morning. Shay is finally answering.
Yes, Miss.
All right, yes, go ahead very quickly. Shay? All right, we're not hearing you anymore. Shay, you're answering?
Good morning, Miss.
Yes, go ahead. Answer, please. Go ahead.
Miss. Repeat the question.
Oh, well, we were calling you from a long time ago, but I'm asking you what do we do to change the states of matter?
Oh.
How can the states of matter be changed? Are you answering?
She's gone. She's gone, Dr.
She's gone. All right. Oh, she's probably having some problems. All right, students, let us continue so we can wrap up readily. So to change the states of matter, put your answers in the chat, all right? We are encouraged to either add heat. So of course, when we added heat to the ice cubes, right? And the heat was coming from the surroundings, right? Good. We didn't actually have a fire, but certainly the surroundings would have been warmer, hotter than the ice cube itself. And so it absorbed the heat from its surroundings and started to melt. All right. So normally to change a state of matter, we can add heat or we can remove heat, that is cool. So we either heat it up or we cool it down. All right. And based on those steps, we can now change from solid to liquid to gas, or in the other direction, right? Good. And we would encounter these processes: freezing, melting, evaporation, condensation. Just to point out that the liquid, when freezing occurs, it occurs at the freezing point, and the freezing point is also the melting point. So water freezes at 0 degrees Celsius, and it also melts at 0 degrees Celsius. So your freezing and your melting point would basically be the same thing. But as it changes state, most times, and your teacher can do that experiment with you at school, the temperature doesn't change while it's changing from the liquid to the solid or the solid to the liquid. It maintains the same 0 degrees, but it's moving from one state to the other. So try to experiment with that. And then of course, when substances or liquids boil, they boil at a particular temperature that is called its boiling point. So let me ask this question. Do substances need to boil in order to evaporate? I want somebody to try to answer that. Yes? And you can probably use an example to explain your reasoning. Do we need to boil substances in order for them to evaporate? All right, so let's hear from somebody. There's a Malachi hand that is raised. Let's see if you're thinking, and make sure you're able to give an example. Go ahead.
No, because you can put, for example, an ice cube out in the sun so it can melt.
So remember, we're talking about evaporation. Evaporation.
Yes, that.
Okay.
You can put like a bowl of water out in the sun, and the sun's heat will turn the water into water vapor.
Okay, and the water had to boil?
No, it did not.
So what does that tell us about evaporation?
There are different ways in which you can evaporate.
Okay, all right. Or we could suggest, you can mute again, Malachi. Or we could basically realize, all right, or conclude, that's the scientific term that we want to use. If we put some water out in the sun and we see that, after a period of time, the volume of the water changes, it gets less. You can try that. Or even consider the water cycle. I was explaining this to a group of students last weekend, right? If you think about the water cycle, a part of the water cycle is evaporation, right? Evaporation from our streams or lakes or seas and so on, right? Do we have to allow the water to boil for that process to occur? No. So it means, therefore, that evaporation can take place at, what's the answer? Any temperature, right? Yes, it can take place at any temperature, but boiling must occur at a specific temperature. So think about that. You can run the experiment, put some water outside. A matter of fact, you can even go further to look at, if we place the water in a broader container as opposed to a smaller, smaller in terms of the surface of the container, right? See what happens. See which one would lose the water or evaporate faster than the other. All right? Okay, so those are some of the concepts that we want to highlight about changes of state. And of course, all of these processes, freezing, melting, evaporation, condensation, are regarded as reversible changes. All right? Reversible changes. All right, so let's look at these questions. I think we have some questions coming up. We'll skip out that one. All right. I'm not sure why I have that on my screen. All right, so pay attention to these questions and increase the volume if necessary. Here is our first question. Class 6C visits the school pond for 5 days and took the measurements as shown in the table. We're told that on one morning it rained, and we're asked on which day of the week would it have most likely rained. We're to support our answer with evidence. So let's look closely at the question. We're to determine which day it most likely rained. And so we need to examine the results in the table. And here we're looking at the air temperature as well as the depth of the water. So let's ask ourselves the question. If it rains, how would that affect the air temperature? And how would that affect the depth of water in the pond? Think about that. So let's look at the results again. If it rains, which day would it most likely have rained? That's correct. It would have been Friday. What's the evidence that we have to support this? Well, if it rains, the temperature would usually get lowered, yes. And certainly the depth of water would also increase. And so Friday would be the most likely answer. Here is our second question. A student is trying to find out if changing the material of a parachute affects the time it takes to fall to the ground. So here is an investigation that is being designed. We're asked to complete the table to show what the student should do. So certainly in an investigation, there are variables or different factors that will affect our investigation, especially if we're thinking about a fair test. So what is a fair test? What usually happens in a fair test? Yes, in a fair test, we're asked to change only one thing while keeping the other variables constant. And so we have different variables to consider. Do you remember the types of variables? So we're usually asked 3 questions. What would you change? So the variable to be changed is called the manipulated variable. Obviously, manipulate means to change. So that is the variable that we change. And then
we would keep some variables the same to ensure that we have a fair test. So the variables that we keep the same, we call that our constant or our controlled variable. And then, based on the change that we make, there's a variable that we need to measure, and that is called our responding variable because it responds to the change that we make. So let's examine the question again. All right, so I'm sorry I touched that ahead of time. So in the chat, you can go ahead and indicate what you would change, what you would measure based on the variables that are shown here, and what would be kept the same. All right, there's almost a square in the background of my presentation. I'm not sure. I'm going to have to check it out afterwards. All right, so we're using the chat. Let me just see some responses in the chat before we actually show the answers of what we would change. Okay, I see there is a comment here for Chelsea Blake. Mrs. Comock, check if we need to remove Chelsea Blake from the chat.
Okay, let me check that.
Thank you very much. All right. Okay, so let's see if we can remember, students, we had warned before, if you're given if you're being disrespectful in the chat, we will remove you from the Zoom session. All right, we'll keep our promises there. So let's go again. So what would we keep the same? So let's examine the question again. How would we complete this table? Which variables would we keep the same? Yes, certainly the height at which we release our parachute should remain the same. The mass of the clay attached to the parachute should also be the same, and the size of our parachute should be the same. Now, what would we change? If we look at the question, we'd realize that the student is changing the material of the parachute, and so that is the variable to be changed. And then what would be measured? When we make that change in the material, what would respond to that change? The time it takes to fall to the ground, and so that is what we would measure. Great job. All right, so let us see if there's a hand. Somebody wants to respond to that question. Let me check what's happening to my screen. Oh, somebody can't hear. All right, remember I asked you to increase the volume on your device. Somebody wanted to answer. Bignell, Rashawn Bignell. Okay, Rashawn Bignell. Can we allow Rashawn Bignell to answer? Let me see if I can take off this off my screen. I'm not sure where it's coming from. Rashawn Bignell.
Miss, I would change the parachute, miss, the size of the parachute, miss.
Why would you change the size of the parachute?
Miss, because the size of the parachute, miss, it will make the speed of when you're falling change, miss.
Mm-hmm. But remember, the question said the person was looking at the question the student was investigating was how changing the material. All right.
Yes, miss.
Yes? So if we're focusing on changing the material, we can't also change the size because we'll be doing two different things. We're changing two different things, and we're only allowed to change one thing. Do you understand that?
Yes, Miss.
Right. So you're asked the student is investigating how changing the material would affect the time it takes for the parachute to land on the ground. So if I change the size and I use a very large parachute and a small one, it's going to affect my investigation because I won't know whether the material had a hand to play in that. All right. So we
Yes,
can
ma'am.
only change one thing at a time. So you can change the material and then you keep the size the same. All right. Okay. Make sense to
Yes,
you?
Miss. Yes,
All
Miss.
right. Okay. All right. So let's go back into this. All right. We're going to show another.
Dr. Taylor, a lot of
Yes.
persons, they keep asking what time will it end?
Okay, we're ending soon.
Okay.
All right. All right, I'm inviting you to look at this video. All right. We're wrapping up. All right. So post to the chat any questions you may have concerning the video. What do you think is happening? What caused the balloon to actually be blown up? Yes. Right. What is happening? What do you know about the processes taking place that would account for that? All right. Any comments? All right, I see Kalicia Harvey will take one response. Kalicia Harvey. Could Bignell close his mic, please? Kalicia Harvey, are we able to unmute Kalicia? Kalicia, all right.
Yes, miss.
Okay, you're answering, you're responding to the video.
Yes, miss. I think it is air pressure that was occurring.
Air pressure. All
Yes,
right.
miss.
So the balloon was able to the size of the balloon changed because of air pressure. Where's that air pressure coming from? If it is air pressure. All right, think about it again. What caused the balloon to basically blow up?
Yeah.
Come again? All right. Let me see the responses in the chat.
All right, if I can. And right, I can't see the responses. Let me see. Okay, so they're saying chemical reaction, mix of the vinegar and powder resulted in a gas. Thank you very much. So there's a gas that was produced from the reaction between the vinegar and the baking soda, or what you may know as baking powder. And the gas that was produced, obviously, with the gas, we know that gases are constantly flowing, they move. So the gas would now be moving and it moves to any available space. And the space that was available would have been from the balloon. So it filled the space in the balloon. And that is why the gas, the balloon blew up. All right, so that would have highlighted for us what we call changes, how materials change, right? Of course, the change can be reversible or irreversible, right? And we note what happens when you have a reversible change, you're able to recover your original material, so no new substance is formed, right? So process of mixing certain materials that forms a mixture or a solution, they are considered to be reversible change because we can separate those mixtures to get back our original materials, right? And as we pointed out, all changes of state are reversible. And then for irreversible, we're usually forming a new substance. So in the case of the video, we formed a gas, carbon dioxide to be exact. And we cannot get back the vinegar and the soda in terms of the original materials. So that is a reversible change. All right, so we're winding down. We wanted to look at this last set of questions, well, second to last. All right, listen carefully and participate by putting your answers in the chat. And if you are not hearing, increase the volume on your device. Here is our question. Droplets of water formed in a window near a pot of hot water. We're asked what best explains why droplets formed on the window. So we're looking for the best explanation. And we need to figure out, where are those droplets coming from? Let's think. Where would they be coming from? What process is actually occurring? So the water, or the water vapor rather, would be coming from the pot of hot water. Now, why would they now form droplets? What is happening to the water vapor? We would realize that the water vapor is condensing on the window, and that is why the droplets form. But is that the question that we're asked to answer? So we're asked, what is the property that the window should have to allow the water vapor to condense on the surface? What do we know about condensation? For condensation to occur, then the water vapor needs a cold or a cooler surface. And so the window must be cold. That's correct. What type of changes is this an example of? Reversible, yes. Can we get back the water vapor? Certainly we can. So it is a reversible process. Here is our second question. A student wanted to find out how the amount of baking soda or powder
would affect the height of a rocket that was created from mixing the baking soda and the vinegar. So here is our diagram showing the rocket being formed. And here's a question that is being asked. What should the student keep the same in this experiment to make it a fair test? Let's examine what we're being asked to do. We're to keep some things the same as we consider a fair test. So as we would remember in a fair test, we would only change one thing and keep everything else the same. Look at our options. The number of teaspoons of baking soda, should we keep that the same? Well, in this experiment, based on the table, we're changing the teaspoons of baking soda. So that would not be kept the same. What would you keep the same? Yes, the type of baking soda and the amount of vinegar that is used. That should be kept the same. Here is a second part to this question. We're asked, based on the data, what is a likely conclusion from this investigation? So let's examine the data that is given in the table. Let's look for pattern or trends. So as seen, as we change the amount of baking soda, as that increases, what happens to the height of the rocket? The height of the rocket is increasing. So we're looking for a likely conclusion. Now, let's look at options B and D. Baking soda reacts with bottled vinegar. Is that a conclusion? We know it reacts, but would that be a properly worded conclusion? And C, if the amount of baking soda is increased, then the rocket height will change. Does that sound like a conclusion? Definitely not. That is actually a hypothesis statement because we're suggesting what we think will happen. So what then is the likely conclusion? As the amount of baking soda increased based on the results, the height of the rocket also increased. Now, what type of change is this an example of? Yes, it is an irreversible change because we cannot get back our original substances used.
All right, great. So I hope you're able to answer those questions, all right? And finally, we are looking at mixtures. I won't take any more responses based on the time, all right? And these are some of the concepts I think you might have, or even if you haven't started mixtures yet, you should be moving to that topic soon. And we would consider, what mixtures are, what are the different types of mixtures that we would have. And of course, once you consider mixtures, you would now need to look at how we can separate them, and there are different methods that are shown here. The methods, of course, are linked to the properties of our substances in the mixture. So if we have something that is soluble in a liquid, then we can only separate it by evaporation, right? But if we have something that is insoluble, then we can separate by filtration or decanting, right? And if we have solids, a mixture made of solids only, different solids, then we can consider the size of the particles and use sieving as our method of separation, all right? So the properties of mixtures, again, we can consider things like how soluble the substance is, how heavy, that is looking at the density of the substance, the properties, if they're magnetic, and of course the particle size. So we have 2 questions on mixtures, and then we'll invite you to share using an exit poll your thoughts on the session. So a student was stirring some salt into water and noticed that the salt disappeared. So the first thing is, I may want to ask, has the salt disappeared? Is that what happened to the salt? would we say the salt disappeared? How can we prove that the salt did not disappear? All right, think about that and put your answers in the chat. All right, so the question is, which word best describes the salty water? If we're thinking of what happens when we mix the salt and the water, right? Which word that is shown best describes the salty water? So let me look in the chat before we give the answer. Yes, thank you for removing some persons who were disobedient. Let me say this is a warning to others who are on the platform. If you continue to post disrespectful comments and other comments in the chat not related to what we're doing, we'll be forced to remove you. All right, so somebody said B, the salty water is soluble. Would you call water, the water soluble, the salty water soluble? Or is it the salt that you added to the water that is soluble? So remember, we're to describe the salty water. Somebody has here D, which is solvent. Do we consider the salty water to be a solvent? Students, look at the question carefully. Look at the question carefully, look at the options. We're describing the salty water. When I mix salt and water, what is formed? Right? So make sure you're looking at the question carefully. It looks like a very simple question, but based on the responses in the chat, you can very easily make a mistake. If you say that the salty water is soluble, you're just describing the salt. So the salt is soluble. That's why it would dissolve in the water. But how would you describe the salty water? That is the question, right? So the salty water would, of course, be called a solution. Remember, when something dissolves in a mixture, yes? When we have a solute, so the substance, which is a solid or whatever substance is being dissolved, is called the solute. And the liquid that you place it in is called the solvent. So the water is a solvent, but the salty water now becomes a solution. So that's the correct terminology. All right. And final question on the mixtures. Please look at this question. All right. The student has a mixture of sand, salt, and water, and it is in beaker X. So that's where the sand, salt, and water is. And they would have carried out the process and were asked which row that is shown here describes what happens after they pour the mixture in beaker X into beaker Y. So look at it carefully. What will be found on the filter paper and what will be found in the beaker? Look at the question carefully. All right, let me look at the responses in the chat. So somebody is saying B. B says sand and salt is in the filter paper. Would salt be in the filter paper? If we pour water on salt, what would happen to the salt? All right, think about that. Okay, let's see if I can see some other responses. So some persons are saying C, B. All right. Persons are still saying B. Remember, students, think carefully, or unless I'm seeing the wrong responses here. So I'm seeing quite a few C's. Yes, so the answer should be C. Why? Because what do we know about sand? Is sand soluble? No, sand is insoluble. Remember, filtration removes insoluble solids. So the sand would remain on the filter paper, right? And salt, which is soluble in water, would now pass through the filter paper
to go into the beaker. So in your beaker, you would have salt and water, all right? And so our answer is C. Okay, all right. And that ends our session. Before you go, we should have sent the link for the poll, but I don't know, it wasn't working. So I'm going to ask you to very quickly in the chat indicate if the session was helpful or if it wasn't helpful or if it was very helpful, very quickly as we wrap up. If you have learned anything that will help in your preparation, and if you would recommend the session to another friend or classmate. If there's anyone who has a burning question, they're not sure, they need something to be clarified, you can raise your hand. If not, just put their responses to these questions in the chat. How helpful this session has been to you? Has it been helpful at all? Have you learned anything that will help in your preparation for your exams? And if you would recommend the session to another person. I see Zariah has her hand up. Can we take one comment from Zariah while you continue to put your responses in the chat? Are we taking a response from Zariah?
Yes, Dr. Taylor.
Okay, thank you.
Thank you, Miss. I couldn't unmute.
Okay, go ahead.
Miss, it was helpful, Miss. But I learned something new because we
Yes.
never learned mixed yet.
Oh, you haven't done mixers as yet. All right, no problem. Okay, that's fine. All right. Anything else you want to add? Was there anything that any concept that you probably had a different understanding of it than what was explained? Is there anything you're still not clear on? Okay, Zariah is gone. All right. Okay, thank you all. Thank you, teachers. Thank you, students. Remember that the session would have been streamed, and so you can check the JTC YouTube channel for the link to the session, and that can be shared with other students who would have missed the session as well.
Please reshare the link, Dr. Campbell.
Okay, let me try. So many things have happened since. Let me see if I can find it again. Oh Lord, this is going so fast. All right, I think that looks like it. So the link, oh dear, what did I, sorry. Come on, I'm supposed to be putting it to everyone. All right, please don't message me yet. Let me put out this link. Oh no. All right, so that's the link in the chat for the YouTube. You can, students, if you had a challenge with hearing, you can go back and listen to that, watch that recording, and of course, share with others. Thanks for joining. Thanks to our other officers who helped to manage the chat and the responses. Mrs. Comock, our Education Officer for Language Arts, Mrs. Russell, another for our education officers, and thanks to Aviel for taking part in sharing our devotional exercise this morning. Thank you, and we will be ending the session in another minute. Bye to everyone.